Okay, so we're going to finish up metamorphic rocks and mountains over the next couple of lectures, and at that point, that'll be what will be on online exam 3, and then we'll be getting into the midterm on Thursday next week. Lots to do. Start looking at reviewing your homework questions, clicker questions, anything from the online exam questions. All of those are kind of the things I use to build the midterm. And the midterm will be here in class. You got to show up for it. And there are no lifelines, no notes or anything. It's strictly all out of your head. Yes?
Are the clicker questions on your slides?
The clicker questions are not on the slides. Oh darn, go figure why. Yeah. No, I figured at that point you could figure it out from the slides, or you were taking notes during class. Okay.
Is there a way to look at the answers to quizzes that we've already taken that close?
I'll see what I can set up. Unfortunately, a lot of times those things, the computer won't let me go back and do that, but I'll try and open that. Okay. Yes?
Will you be posting a study guide?
There is a midterm study guide that we have on the net, and that's usually about what we do. Okay. There are study guide questions at the end of each chapter in the online ebook, and those are good. I have all of the clicker slides posted online, and so every lecture is there. So those are basically what we've been talking about. So those are good to review and flip through and make sure you understand what we were talking about there. And, you know, your notes, obviously. So between that and the clicker slides, you ought to have a pretty good outline of what we've been doing.
I'm sorry, just to clarify, so the clicker slides that we have done are on.
They're on the e-learning page, yeah. Go to the content tab. They'll be on there. Okay, you may actually find a couple of sets of clicker slides there. I have my set, and they're just slightly different than what we do in class. I pull out the clicker slides, and I try and make them a little more informative. Sometimes the slides we show just a picture, and that doesn't tell you too much without the verbiage. So I tend to pull that out and put in things that are a little more self-explanatory. So you'll see a little difference. There's also a set of slides that's put together by the book publisher, and I put those on the e-learning page also. So you've got a couple of resources there if you want. All right. Okay, metamorphic rocks, whether you like it or not, they're coming. And I think I've even got my clicker fixed. It's been a few weeks so far. Okay, we're back to the rock cycle. You make any rock out of any rock. And now we're looking at the rocks we make by applying heat and pressure. And it's just like a caterpillar metamorphosing out of its cocoon and turning from this ugly caterpillar to this beautiful butterfly. This is exactly what's going on with these rocks. We're changing them. And we're changing them from the conditions that they find themselves beginning with to this new set of conditions being imposed on them. And the idea is they're going to go from being stable in their original conditions to being unstable in their new conditions, and they've got to make that adjustment to get back to stability and equilibrium. So that's what we see them going through. Metamorphism simply means change, morph, changing form. And we're looking at heat and pressure primarily, but this is going to be causing chemical reactions. So we're going to have a bunch of loose ions out there running around, waiting to react with other things. So we trigger a bunch of chemical reactions, and those in turn trigger reactions that are going on. And because we're talking about heat and pressure, we usually talk about things that are fairly deep within the Earth to get those kinds of elevated pressures and temperatures. In fact, for the most part, we're talking at depths of about, 10 kilometers. That's about 6 miles below the surface. Now remember, we are gonna raise temperatures, but we can't raise them too much or else we're gonna melt the rock. And if we melt the rock, what have we done in the rock cycle? We're back to igneous, aren't we? So we don't wanna take it quite that far. So we wanna get it up there to where the temperatures will cause chemical reactions and change, but not enough to melt the material, completely disassociate it. So that means we're gonna have to keep temperatures somewhere below about 450 degrees Fahrenheit. After that, remember, at the bottom of Bowen's reaction series there was about 700 degrees C, and we're gonna start to melt things pretty fast. So we don't wanna get too carried away with this. So heat's the big thing, pressure's the big thing, and we're going to talk about two different types of pressure. We're going to talk about pressure that's lithostatic or confining pressure, simply loading something by burying it. And now pressure is just going to be applied evenly around the entire body. It doesn't matter what direction I approach the body from, it's getting pressured up the same regardless of direction. The other is directed pressure, as you might guess. And this would be where I've got, for instance, a convergent plate boundary, where two plates are smashing into each other. Now I've got directed pressure along the axis of that impact. So that's going to present